Hi, I'm Dan Cortopassi. Welcome to Model Building. In this installment of the series, I'm continuing my build of a freelanced N-scale narrow gauge steam locomotive. So far in this build, I've modified an N-scale Rivarossi 040 boiler to fit my Marklin Z 260 mechanism. I've added a 3D printed cab from Shapeways and reworked some details and added more details to the top of the boiler. One of my design specs for this model is that it have a working front coupler. In this episode, I'm going to work on that. My goals for this episode are to attach a pilot deck to the chassis, install a working front coupler, and attach a 3D printed pilot to the model. On Shapeways, I found something being sold as Nn3 conversion parts. The 3D printed set includes the cab I fitted in the last episode. It also includes a tender body and some details including a smokestack and domes and a pilot. First, I want to see if my Microtrains 905 couplers will fit through the opening in the pilot. That it doesn't is disappointing but not surprising. I'll need to make the opening both wider and deeper. Since the incident with the cracked cab in the last episode, I know that this 3D printed material is fragile. I'm using some small files and proceeding with caution. After a while, the opening is much bigger. If you recall, I originally bought 2 of the Nn3 conversion part kits, which is how I had a spare cab for the last episode. Since I also have a spare pilot, it's easy to see how much material I removed. The modified pilot is on the left, and the stock pilot is on the right. The coupler almost fits now, but it's still a little tight side to side. I'm going to file a small amount of material from the sides of the coupler box. That looks better. Now it can go all the way into the opening. Before I can figure out how to mount the pilot on the engine, I'll need to remove the extended metal piece on the front of the pilot truck. It'll be easier to work on the pilot truck off the model. First, I'll remove the front screw on the engine's bottom cover plate. Then I'll loosen the rear screw. It doesn't need to come out all the way. Now the pilot truck can be removed. I'll use some metal cutters to snip off the metal piece. Then I'll use my motor tool and flat files to finish off the cut. When I'm done, the pilot truck only extends to the front wheels. Now that the pilot truck is shorter, I can get the back of a Microtrain Z-scale coupler height gauge close to the model. The top of the shelf on the back of the height gauge indicates the height for the bottom of the coupler mount. There's room to mount something under the piece of the chassis that extends forward over the pilot truck. With the pilot truck off the model again, you can see that the front part of the chassis is curved on the bottom. That's going to make it hard to attach anything there. I'm going to flatten this area with some filing. I used a couple of different flat files. Thankfully, the metal is fairly soft, so it only took a few minutes to flatten out the area. Looking through my stash of hobby supplies, I found some 0.25 by 1/4 inch brass strip from K&S, part number 8235. I'm going to mark the brass with a file so that I can cut it to the same width as the pilot. This will become my pilot deck. The pilot deck will mount under the part of the chassis that I filed. I've done some measuring and found the spot where I should drill a hole for a mounting screw. With the brass taped to some scrap wood to keep it still, I'll start drilling a small pilot hole with a pin vise. I'll follow up with a 1.6mm drill to enlarge the hole. While holding the pilot deck centered under the chassis, I'll use a drill bit to make a small indentation to mark where I need to drill a hole. I'll use a pin vise to deepen the indentation. Then I'll use a number 64 drill bit in my motor tool to complete the pilot hole. I'll finish up with a 2mm drill to clear the mounting screw threads. I'll be using a 2mm by 0.4 pitch metric screw to attach the pilot. The tap drill size is 1.6mm, the same as I already used to drill a hole in the brass pilot deck. Now I can use a 2mm by 0.4 pitch tap to thread the hole. I go slow when using taps and back up frequently to get rid of metal shavings. I found Northwest Shortline part 1203-5 in my stash of supplies. It has 3mm long screws that match the threads I just cut. With the pilot attached, the screw sticks down a little below the pilot deck. I'll use my motor tool to shave off the excess. A few passes with a file will make the screw flush with the bottom of the deck. Let's check the coupler mounting height. This looks just about perfect. I mocked up the engine with the pilot and coupler in their approximate locations to check the overall proportions. This looks like it should work. With the pilot deck off the model and taped to some scrap wood, I'm using a pin vise to make a dimple to mark the location of the coupler mounting screw. I'll drill out the hole with a number 62 drill bit. Then I can use a 0090 tap to thread the hole. Now I can mount the pilot deck and coupler to the chassis. The coupler height matches the Microtrain Z height gauge. Now that the pilot is mechanically complete, I want to make it look better. I'll start by grinding some material from the rear. After using my motor tool, I'll finish up with a small square file. Next, I'll use my motor tool to grind down the coupler screw so that it's flush with the top of the pilot deck. I'll use a file to finish it off. The wider part of the pilot now ends at about the same place the steps on the side of the smoke box begin. After filing and grinding, I like to use a soft brush to get rid of any metal shavings. With the pilot off the model once more, I'll roughen up the top with a file. Then I'll use some CA before screwing it back onto the chassis. This should help to keep it from rotating around the screw. The screw needs to be tight enough for it to stay put, but it's important not to over-tighten it and strip the threads. Right now the 3D printed pilot doesn't fit very well with the coupler and pilot deck. I'm going to remove some material from the back of the pilot to see if I can get it to work better. In the last episode I broke a 3D printed cab. This time it's the pilot that broke. I have a spare, but I'm not sure that this idea is going to work. If I do the same thing again, I'll likely get the same result. It's time to rethink things a bit. I'm going to measure the distance between the coupler and the edge of the pilot deck. It's about 2.5 N-scale feet. This is some 040 square styrene. I'm going to cut 2 pieces of this to fit to make a pilot beam. I'll glue each piece on using CA. The pilot beam pieces stick out a little beyond the edge of the pilot deck. I'll carefully cut and file them to fit. I have an idea to experiment with the broken pilot. I'll use my motor tool to trim off what's left of the pilot beam. Holding the part under the coupler, it looks like everything should fit. Now that I know it'll work, I've done some work on the spare pilot, being very careful with the fragile material. I widened the coupler opening as with the original pilot and filed off most of the pilot beam. I'll use some CA to attach the 3D printed pilot to the pilot beam that I made. It looks like there's plenty of clearance between the pilot and the rail. Now that the pilot is attached, I want to reinforce it for durability. I'll add a couple more pieces of 040 square styrene behind the pilot beam to give the pilot some additional support. I'll file these flush with the edges of the pilot deck. It seems fairly solid now. It probably won't survive being dropped, but I think it should hold up for normal operation. While checking clearances, I noticed that the top of the pilot truck is touching the bottom of the front coupler. To fix this, I'll need to remove the wheels. I'll just pull on them until one wheel comes off. Holding the pilot truck in place below but in line with its normal position, I can see that the coupler box extends back to about where the axle holes are. There are a couple of slots above the axle holes. I'm going to use my motor tool to grind the top part of the pilot truck where the slots are. I'll finish up with a file. Now the truck is notched but still has the wheel slots intact so that the wheels won't fall out. Since I'm not aware of an Nn3 Z standards gauge, I'm using my microtrain's height gauge to make sure that the wheels are at the right distance apart when reassembling the pilot truck. The pilot wheels now have some room to go up and down, so the clearance under the coupler should be sufficient. The pilot truck still has enough side-to-side swing to stay on the rails when the locomotive goes around a curve. I've mocked up the engine and I like the look of it so far. The proportions of the pilot look about right to me. I think this is a good place to leave things for now. Modifying a tiny and somewhat expensive mechanism can be daunting. Very carefully consider what needs to be done and check your work often to make sure that what you're doing isn't going to create problems. When doing custom work like this, detail parts aren't always available. Sometimes the best option is to make parts out of raw materials. A piece of brass, a screw, and some plastic strips were all that was needed to create the pilot deck for this model. Sometimes things don't work the way you first envision them. I had to rethink how I was going to mount the pilot after the first one broke. I think the way I ended up doing it is superior in some ways, so don't be afraid of making minor course corrections in the middle of a project. For this project, I've been keeping a tally of how much I've been spending. The total from the last episode was $95. The Shapeways detail parts set I bought that included the pilot was about $15, but I already accounted for that in a previous episode. I paid about $7 for the Microtrain's 905 assembled couplers, which come with 2 pair in a package. Since this locomotive will ultimately need 2 couplers, or half the package, I'll call it $3.50. I'll round it up to an even $4. At the time I bought it, the K&S brass stock was about $1. I only used a small portion of this model, but just to keep it simple, I'll call it $1. That brings us to about $100 in parts so far for this build. I'm pretty happy with how this engine is turning out so far. I'm going to continue working on it next time. Stay tuned, and thanks for watching.